Hello friend, in this video lecture we are going to start the matrix Eigen value problem. First write the problem. Find the eigenvalue and eigenvector of the matrix A is equal to 5 0 1 0 minus 2 0 1 0 5. First write the given matrix. Solution. First write the given matrix. A is equal to 5 0 1 0 minus 2 0 1 0 5. Then we write the characteristic equation of matrix is given by mod of A minus lambda I is equal to 0. Here lambda is eigenvalue and I is identity matrix. Then write 5 minus lambda 0 1 0 2 minus 2 minus lambda 0 and 1 0 5 minus lambda. Here A matrix A, lambda is eigenvector and I is 3 by 3 identity matrix, that is 1 0 0 0 1 0 and 0 0 1, and multiplication of this and mod of this right in this form, and then we get 5 minus lambda into minus 2 minus lambda 5 minus lambda minus 0 plus here 1, therefore 2 minus 2 lambda 0 1 into 0 minus of minus 2 minus lambda is equal to 0, because mod of this is equal to 0. Then minus 5 minus lambda into 5 minus lambda into 2 plus lambda plus 2 plus lambda is equal to 0. Then 2 plus lambda into 25 minus 10 lambda plus lambda square minus 2 plus lambda is equal to 0. Then 2 plus lambda into lambda square minus 10 lambda plus 24 is equal to 0. Then lambda plus 2, lambda minus 4 and lambda minus 6 is equal to 0. Therefore lambda is equal to minus 2, lambda 4 is equal to 4 and lambda is equal to 6 are the required eigenvalue of given matrix. Now we find corresponding eigenvector by using equation A minus lambda I into xi is equal to 0, means x into a into xi is equal to lambda I into xi. Then write a into x1, x2, x3 is equal to lambda I into x1, x2, x3. That is equation 1. Then putting the matrix for lambda is equal to -2, we find eigenvector xi x1 is equal to x1, x2, x3. Then from equation 1, a into x1, x2, x3 is equal to -2 into x1, x2, x3. Then put a is equal to 5, 0, 1, 0, -2, 0, 1, 0, 5. x1, x2, x3 is equal to -2x1, -2x2, -2x3. Then by calculating 5x1 plus x3 is equal to -2x1, -2x2 is equal to -2x2, and x1 plus 5x3 is equal to -2x3. Then 7x1 plus x3 is equal to 0, and x1 plus 7x3 is equal to 0. The solution is x1 is equal to x3 is equal to 0, and x2 is arbitrarily. We take x2 is equal to 1, then x1 is equal to 0, 1, 0. This is the first eigenvector for lambda is equal to -2. Then lambda is equal to 4. We find eigenvector x2 is equal to x1, x2, x3. Then from equation 1, a into x1, x2, x3 is equal to 4 into x1, x2, x3. That is put the value of a, then we get 5, 0, 1, 0, -2, 0, 1, 0, 5 into x1, x2, x3 is equal to 4x1, 4x2, 4x3. Then we multiply these two matrix, then we get 5x1 plus x3 is equal to 4x1 minus 2x2 is equal to 4x2, and x1 plus 5x3 is equal to 4x3. x1 plus x3 is equal to 0, and x1 plus x3 is equal to 0 means x2 is equal to 0. x1 is equal to minus x3, and we choose in particular value of x1 is equal to 1 upon under root 2, and x3 is equal to minus 1 upon under root 2, and we get x1 square plus x2 square plus x3 square is equal to 1, and then we get the second eigenvector is 1 upon under root 2, 0 minus 1 upon under root 2. That is the second eigenvector. Then third, for lambda is equal to 6, we find the eigenvector x3 is equal to x1, x2, x3. Then from equation 1, write same procedure, a into x1, x2, x3 is equal to 6 into x1, x2, x3. Then putting the value of a 5, 0, 1, 0 minus 2, 0, and 1, 0, 5. x1, x2, x3 is equal to 6x1, 6x2, 6x3. Then we get 5x1 plus x3 is equal to 6x1 minus 2x2 is equal to 6x2, and x1 plus 5x3 is equal to 6x3. Then we get x2 is equal to 0. Then x1 minus x3 is equal to 0 means x1 is equal to x3, and choosing x1 is equal to x3 is equal to 1 by root 2. Then we get the eigenvector x3 is equal to 1 upon under root 2, 0, 1 upon under root 2. And then hence x1, x2 and x3 are required eigenvector corresponding to the eigenvalue lambda 1, lambda 2 and lambda 3. For lambda is equal to minus lambda 1 is equal to minus 2, then eigenvector is given as 0, 1, 0, and for lambda is equal to 4, we get the eigenvector x2, that is x1, and then we get x2. x2 is equal to 1 upon root 2, 0 minus 1 upon root 2, and for lambda is equal to 6, we get eigenvector x3 is equal to 1 upon root 2, 0, 1 upon root 2, that is x3, and which is the required solution of eigenvalue, problem. Thank you.